Given 2x minus y equals 1, and 3x plus 2y equals 12, we are required to solve for x and y simultaneously, firstly algebraically, and then graphically. There are two basic ways to solve linear equations simultaneously. The first is by substitution, and the second by elimination. Using the first method of substitution, we isolate one of the variables from one of the two equations, substitute this expression in the second equation, and solve for the first variable. Once we have the value of the first variable, in this case, x equals 2, we substitute this value of x into either of the original equations to get the value of the second variable. The solution to this pair of linear equations is therefore x equals 2 and y equals 3. Using the second method of elimination, we will sometimes need to manipulate either one or both of the equations, such that one of the variables can be eliminated either by adding or subtracting the terms of either equation. In this case, we will multiply the first equation by 2, such that the coefficient of y in either equation is similar. By similar, we mean that the numerical value of the coefficients are the same, but the signs are different. In other words, 2y versus minus 2y. We can now add the newly formed equation with equation 2 to get 7x equals 14, and therefore x equals 2. All that is left to do is to substitute this value of x into either of the original equations, which gives us y equals 3. To solve these linear equations graphically, we first need to sketch the two functions, which we will do by using the dual intercept method. The x-intercept of a function occurs when the y values are 0, so the x-intercept for the first function is the point, a half 0. Likewise, the y-intercept of a function occurs when the x values of the function are 0. The y-intercept of the first function is therefore the point, 0 minus 1. Similarly, the x-intercept of the second function is the point, 4, 0. And the y-intercept is 0, 6. The solution to the two linear equations is the point of intersection, which is the point 2, 3. We are now required to also sketch the graph of 2y plus x equals 4. The x-intercept of this function is the point, 4, 0. And the y-intercept is the point 0, 2. The last thing we need to do is to shade the region represented by the three listed linear inequalities. 2x minus y is less than or equal to 1. 3x plus 2y is less than or equal to 12. And 2y plus x is greater than or equal to 4. Note that the shaded region will indicate the solution to these three inequalities. Before we find the solution to these inequalities, we first need to express each inequality with the variable y being the subject of the formula. Secondly, note that the inequality signs, greater than, and greater than or equal to, with respect to the variable y, means that the solution lies above and to the right of the line. And the inequalities, less than, and less than or equal to, with respect to the variable y, means that the solution lies below and to the left of the line. So, for the function, y is greater than or equal to 2x minus 1, we shade to the right of the green line, because the inequality is y is greater than or equal to. For the function, y is less than or equal to minus 3x over 2 plus 6, we shade to the left of the red line, because the inequality sign is y is less than or equal to. And for the function, y is greater than or equal to minus a half x plus 2, we shade above the black line, because the inequality is y is greater than or equal to. Taking all three solutions into account, we shade the region indicated, as it satisfies all three solutions to the linear inequalities. For more videos like this, hit the subscribe button in the bottom right corner of your screen. Thanks for watching.